This is Earth's future. Our sun will die. But how long do we have? When will it run out of fuel? And what will that mean for us? What exactly will happen on Earth when the sun approaches the end of its life? Welcome to New Nature. Over the past 3 months, we've worked with leading scientists, astrophotographers, and VFX artists to reveal the sun as you've never seen it before. This is a journey through groundbreaking science, breathtaking visuals, and the incredible story of our star. From the start to its very end. The sun powers life, shapes climates, and drives evolution. Understanding its story helps us understand our own. But to know the sun's future, we need to rewind and go back to its beginnings. This is our Milky Way galaxy. 4.6 billion years ago, before our sun existed, the galaxy was a chaotic mix of gas and dust. Somewhere in space, suspended by gravity in one of the Milky Way's spiral arms, was a cold, swirling cloud of gas and dust. Over time, gravity pulled this gas and dust together, causing the cloud's core to heat up and become denser and denser. As more and more material got pulled in, pressure and temperature increased drastically, until hydrogen atoms overcome their natural repulsion and fuse into helium, releasing a huge amount of energy. This process, called nuclear fusion, ignited the sun and made it shine. In a way, gravity turned chaos into light. But how do we know this? What you're looking at here is StarForge, a simulation that shows how clouds of gas collapse to form stars. It condenses billions of years of star formation into a few moments. It's a beautiful dance of gas and dust coming together to form stars like ours. It set the perfect conditions for Earth to evolve life. We see and feel the sun every day. But have you ever stopped to wonder, what does it actually look like up close if it wasn't so bright? This here might look like the sun you know. But what you're actually seeing is something hidden from the human eye. Scientists use ultraviolet imaging to reveal electromagnetic activity you could never see otherwise. So, if this is not the real view of the sun, then what would it actually look like up close to the naked eye if you could look at it?